Hello guys, hopefully everyone is fine. In today's video, we will be discussing the concept of Huffman coding tree using greedy algorithm. Now the important point that we have to explore is that there is a message which is given and which is supposed to be transmitted to the receiver. So the message size I have to calculate. The message size would be it's 3, 6, 9, 12, 15 and 5, 20. So this is a 20 characters message that is supposed to be transmitted to the receiver. Now if I have to calculate 20, this is 20 characters, then every character has its own significance. How? Because capital A is having a sky value of 65, B is 66 and so on, right? So every character can be represented in binary form. So if a decimal, I have a decimal number 65, I want to convert it to binary. Yes, I can convert it to binary. A value can be obtained as 0, 1, 5 zeros and 1. So this is a binary form of this decimal number. You have to learn how to convert a decimal number into a binary number for this. So every character is of 8 bits and there are 20 characters. So it means if I have to total size of message is 20 characters, every character is of 8 bits. So total message size is 160 bits message that is supposed to be transmitted. So this is one way if I have a direct message transfer without any kind of encoding. Now what is the size? The size of the message that is supposed to be transferred is 160 bits, which is too long, so which can be transcoded or encoded. There are many ways of doing so. First way of transcoding this message is a representation method. In representation method, guys, what we have to do is that firstly we have to see how many characters we have, how many different types of characters we have. We have got A, we have got B, we have got C, we have got D, we have got E. Guys, if there are only two characters, so either it can be represented as 0 or it can be represented as 1. Now the point is, if let's say there are 3 characters, so either it can be represented as 0, 0, 0, 1, 1, 0. If let's say there are 4 characters, it can be represented as 1, 1. But unfortunately, there are 5 characters to it. So 5 characters means different sorts of representation, means minimum number of representation can be of 3 digits. And how the 3 digits representation can be done? We have got A. Let's say we're writing character. We are writing their count. Let's say we are writing count, and we are talking about their representation. So if let's say A character is there, B character, let's say C character, D character and E character. So A character is appearing how many times? We have to calculate 1, 2, 3. 3 times A is appearing, B is appearing 1, 2, 3, 4, 5. B is appearing 5 times. C is appearing 1, 2, 3, 4, 5, 6. 6 times C is appearing. D is appearing 1, 2, 3, 4 times, and E is appearing 1 and 2 times. E is appearing. So these are the counts that we are having. Now we have to represent. We can because it is 5 character, it cannot be represented in minimum 2 bits. So maximum number of bits it has to be represented is with 3 bits. I can put it as 0, 0, 0. This is my representation. I can give any value, but minimum number will be 3. I can give it 0, 0, 1. I can give it 0, 1, 0, 0, 1, 1, 1, 0, 0. So this is how I just represent them, the values. Now the point is, instead of I send all the 8 bits of B, all the 8 bits of C, all the certain values, I would rather send that B is containing 0, 0, 1. C is containing 0, 1, 0. In at least message size is compressed. For a receiver to receive that, if I am putting B as 001, how will receiver understand that B001, we have to send this table information also. So it means how many things we have to transmit. Firstly, a message is calculated, entire message size is calculated by your table information. Table information is very, very important. Then whatever you have represented with, that is important. And the table information contains how much table size it has, what are the ways in which it can be represented, and representation values, and we have to obviously calculate the representation along with total size. So the table information can be calculated as, like for an example guys, if I have to calculate these number of bits, so how many bits we have? 3 bits from this, 3 bits from this, 3, 3 and 3. So total number of bits are 15 bits, right? This is first part. So it means message that will be calculated is 15 plus. Now how many times they are appearing? That is also pretty important. Why? Because if this 3 is coming 3 times, we have to calculate this as well, right? So this is first thing, right? Now this entire message is of how many characters? 20 characters. Every bit is of how many, every character is of how many bits represented? It is represented in 3 bits. So it means these are total 20 characters, and every character is represented as 3 bits. It is 20 multiplied with 3. So this is 60 plus 15. This is definitely certain. Now we have to calculate this. We all need to understand this fact is that every character that we have mentioned is by default of 8 bits. We all know that a value is 65. 65 is represented as 0, 1, 5 times 0 and then 1, right? So the important point over here is that this character A is of 8 bits. This is of 8 bits, 8 bits, and total this is 40 bits, right? So we have got 15 plus 20 multiplied with 3 plus 40 bits. Why? Because we cannot ignore this information also. This information and this information cannot be ignored, because these both are table information, and this is obviously the message, and every message, every character is represented as 3 bits. So 20 multiplied by 15, 20 multiplied by 3 is 60, plus 15 is 75, plus 40 is 105. So entire message size is 115. This is also another way of calculating it, and definitely message is compressed, message is reduced. From 160 we went to 115. Now the second method is also known as this method is known as Huffman coding tree. So your Huffman coding tree is represented in the form of, this is a greedy algorithm. Greedy algorithm will always target the minimum possible values or the maximum possible values or the appearance of their occurrences. So we have to firstly get the table done again. So we have character. Now we have how many times they are appearing. Now let's see, A, B, C, D and E is appearing 2 times, A is appearing 3 times, B is appearing 5 times, C is appearing 6 times and D is appearing 4 times. Now on the basis of their appearance I will create a tree. How? Obviously I'll start from a lower perspective. We have got since this problem is known as a minimization problem. You know what is minimization problem? Minimization problem is a problem in which we have to reduce some value, right? Or you target a lower value. We are targeting a lower size. So it's a minimization value. So we have got character. we have got count, right? So we have got characters such as A, B, C, D and E, 3, 2, 4, 6 and 5. So I'm going to arrange as per the lower occurrences of the value. So I'll take E is appearing 2 times. I'll take 2 and E. Then A is appearing 3 times. Then D is appearing 4 times. B is appearing 5 times and E is appearing 6 times. What I will do, I'll take the minimum 2 values and construct a root out of it. 2 plus 3 becomes 5. So I create a root on the basis of 5. Now I have to take minimum 2 values out of the possible values. So out of possible values we have 5, 4, 5, 6. So which is lesser? Let's say 5, 4, 5, 6. So this 5 or this 5, you can pick any value. So I'll rather pick 4 and 5 and I'll get 9. This I can pick, or I can pick this 4 with this 5 and this becomes 9. I can pick this also, right? So this is another thing that I have picked. Now I have to pick from 9, 5 and 6, which is lower. So 5 plus 6 becomes 11. So 5 and 6 are lower. Now I have to create, now there is 9 and 11. I have to create a tree. This becomes 20. So guys, we have got a particular tree. Now you have to represent. I'll do one thing in tree. I'll put the left node as 0 or right node as 1. So I'll put all the left node values as 0 and all the right nodes as 1. Right? Now, what is the representation logic that I have to use? I have to see how many bits are used to reach a particular character. For reaching E, I am encountering 3 zeros, 0, 0 and 0. So I'm putting it as 000, right? Then I have to reach A. This is 0, 0, 1, 0, 0, 1. Then I have to reach D. It is 0 and 1. Right? I have to reach B, 1, 0. So it is 1, 0. I have to reach E. It is 1, 1. This is also known as Huffman coding representation, and this is the representation, guys. And remember, last time around we had 3 bits for every character. Here we are not having that. Here we are having 2, 2, 2 for B, C, D, which was 3, 3, 3 for B, C, D in the previous possible value. Now how we have to calculate the message size? Very, very simple. How the message size is calculated? Firstly, message size would be table information, whatever table information that is there, and total characters, right? Total characters that are there in this. And if I have to count this whole particular thing, total table information is calculated as every character A, B, C, D, E are of 8 bits each. So if they all are 8 bits each, it will be 8 multiplied by 5 plus how many bits we are using for this? 3, 2, 2, 7, 9 and 12. 12 bits we are using for this, right? So this is your table information, and 8 multiplied by 5 is 40, and 40 plus 12, this is known as 52. And now we have to calculate total number of characters. So total number of characters can be calculated as see, A is 001, 3 characters are there, 3 and it is coming for 3 times, plus total number of characters. This is 2 bits and it is appearing for 5 times. So 2 multiplied by 5. This is also 2 bits and it is appearing for 6 times. This is 2 bits coming for 4 times and 3 bits coming for 2 times. So this is total number of characters for a particular string. So we got 52 plus this is 9 plus 10 19 plus 12 31 plus 8 39 plus 6 45. So 52 plus 45 is 97, and guys, we have reduced a message size from 160 200 and let's say 15 to 97. So as per Huffman coding or encoding, we have reduced the message size to be transmitted. Every information is important, whether it is table information or whether it is total number of characters. So if you like this video, kindly like, share and subscribe, and kindly support us in this initiative. We will be very thankful. Thank you very much.